All right. So I want to quickly just go over, and I did it on the video, so I'm not trying to not reward people for watching it, but I want to make sure that we're all on the same page with this. I want to make sure that we're understanding how to do weaks, okay? Weak acid, weak bases. A strong compound, by watching the video, should know, besides accents. I'm not saying I'm good at them, I'm just saying that was pretty obvious.
It's pretty good. I'll give it to you.
The background on that, by the way, is I made that video like 2 or 3 years ago, and it was like 2 in the morning, and that's literally what came out of my mouth. I just opened my mouth, and I'm like, I'm going with it. Here we go. And why I stopped doing it is that my throat hurt so much that I had to give up. Like, I was fighting through about 3 problems already. It was hurting. All right, so if you have any strong acid or strong base, okay? How do I know? Let's make sure we get this out of the way right now. There are 7 of these, and anything, we learned this in the summer. Group 1A and hydroxides, or 2A hydroxides. Anybody remember the little symbol or the acronym we remember with that? There's 3 letters. It's a TV network. CB. NBC. That's good. Nitrogen, boron, carbon. CBS. The oxygen network. Actually, that works. So, for example, like LiOH, right? Anything like that? This one, an example. CaOH2. Okay. Why are those important? Strong acids and strong bases, whatever I say. Hey, what's up? Whatever compound I give you, that's the molarity of that is the molarity of the ion that you need. So I'll give you 2 examples quickly. 5.15 molar of, let's go HBr. That means I have 0.15 molar of H+, because it completely dissociates based on the video. This one, let me show you something really important. 0.15 molar of this is a little different. Anybody want to tell me what the molarity of that is? This is unique. It is double because of that guy right there. So be careful, there are 3 strong bases that'll get you. If it's LiOH, that would still be 0.15, right? Because it's just OH. Okay, so number 9 and number 10, I give you a concentration. You go, oh, that's strong. Then I'm already dealing with H pluses. That's all of the H plus. I'm all good. I'm good to go. But I do want to make sure that we do a weak solution. So I'm going to do a weak base. Bases are always more work. The reason why is that base is in terms of OH, which is POH, and everything is about pH. So when I'm doing acid problems, it's half the work. Well, maybe not half, that's probably exaggerated, but it's less. Okay, so let's do, and if you've done it, you can quickly check your work. I'm not going to start completely from scratch. I'm going to look at number 12 quickly, and then we're going to get into a couple things on your new packets. I'm going to do a couple problems for you right away, so that'll be kind of nice. And then I'm going to talk about salts, okay, and get you going. I'm handing out these packets a little early because you're going to know how to do all this already. So number 12, what it basically says, and again, I want to get in this as quickly as I can here. Bless you. That's what I'm dealing with. So let me just... Okay, big deal. I need you to understand this. If you're sitting here and you're constantly, I don't know if this is strong or weak or strong or weak. If it has a K, It's weak. Period. If it has a K, it's weak. It's not a guess. Because a K tells me how far it goes across. A strong, it doesn't even have a K because it's so big. It's completely 100%, or we assume it to be, so it's going all the way to the right. Okay? So, great, I'm going to run out of room. So we need to write a chemical reaction to this. Now, an acid, I need you to just be aware that writing acids are easier too. Because if you have this, technically, and actually strongs, usually we just do one line, we can just say this. What is H+? What was the other ion way of writing it? H3O+. We can write acids like this, we just don't need to. Everything is done in water. So when I have this with this, technically it becomes this with that. But I can assume it's gone. The reason why is that I don't need that OH. But with bases, I need OHs. Because bases are in terms of POH. And acids are in terms of pH. H+, acid. OH, base. So, when I write these, bless you, I need, when in doubt, react it with water. When in doubt, react it with water, no matter what. Because the worst case scenario, you'll just get this. Again, acids are much easier to write because you can just break it off into its two ions. But if you don't do it with, if you just have this break up, what is this going to break up into? N and H? You need an H+ or an OH on the right side of an equation, or you can't do any pH problems. You cannot find a pH. So what does this do? Go back to what you know. This is a base. It's telling me it's a base. Now the accent's coming into my head. It's a base. So what does that do? It gains hydrogen. Okay, that's not quite it. No, that's like a boogeyman kind of thing. It gains hydrogen. So it's going to gain. We'll pretend that was good. So because of that, that's what occurs, okay? So speeding this up now. This is an ice box. You can do as much or as little as you want. Like some people don't even do the lines. I do think it's vital to do the double line. If you're not, like, I don't do lines. I only write it, like, I don't even write the letters anymore. That's how good I am. I do ice boxes without doing ice boxes. But what I am going to urge you, I don't care if you are the 6 that got a 39 or if you got a 9. No one got a 9. Except Edgar. At least organize as much as you know. So you'll see it written like this. Sometimes you'll just see this written larger without anything here, and this just is under both of these. But I need you to understand that the water does not get attention because that is not part of my equilibrium expression because it's liquid, right? So then we go forward, and again, I'm almost done. So if you've done this one already, great. Those are zeros in the beginning. So then my change would be plus x, minus x. And then what I'm doing is I'm placing that all in here. Now, I'm going to show this to you right away. I'm going to try to show it this one time. You will start seeing trends. You guys are very smart. Almost every weak acid, weak base problem will give you an initial amount and that's it. And it'll say, hey, what's the pH? Please note, it's the same format every single time. What it's going to be? It's going to be x squared over the initial minus x. I'll say that again. Every time that they give you an initial amount and that's it, the result will simply be x squared over the initial minus x. So if you're not given anything else, it's when we start giving you other things. Like, oh, hey, here's an acid and something else over here. Okay, that's, I think, when we will need an ice box. But if you notice that it's just one thing, a lot of you will start to graduate quickly to, well, that's just x squared over initial minus x, and it equals my k. Okay? A couple things, because you're going to see it today. If you're dealing with a base, it better be a B. I'll show you how we handle that if it's not. If you're dealing with an acid, so it'd be H+ on this side, you better be dealing with an A. Okay? So then you can do the rest. This is good to go. It's barely, but it's good to go, and I will show that to you very shortly. But I cross that out, I solve for it, and notice, X on the bottom is OH minus. So how I usually write it is X equals OH minus, because it's all about H plus or OH minus. And then I go forward. Okay? So if you're good or not with that, that's one I wanted to show. And I want to go to problem 3 on lesson 18. So if you want to flip to the back right away, I'm going to jump the gun here a little bit. I'm going to do a couple, and then I want to end with talking about salts. So just so you understand, lesson 18 is all about just acids and bases. You probably know a lot of it already. Lesson 19 is about weak acids, weak bases. I know I have a smart board and everything else, but I kind of like writing on the board sometimes. I can write there and then it writes on the screen. I know, it's fancy. Do you want to see? We could do it. Let's do it. Let's do it. No, we'll do it. We're going to do it. You want to do it? Let's do it.
This is smart board.
Huh?
Can you like
Okay. So let's take a look at problem 3. That just happened. Okay, so what it says is I have 25 mils of 0.120 molar HCl. Okay, and then you have 4 situations that you're doing to the acid. And I want you just to be aware of what that is. Okay, so what are we doing to each of these? First off, strong acid. I hope that we agree with that. So, letter A. It says that I add 40 mils of H2O. Simply put, what are you doing to the acid? You're just diluting it, right? You're just diluting it. So, when I need, it says calculate the concentration of H+. That's all I want. So keep in mind, please, if I want H+, what is that? That's moles over liters. Okay? So, what would be smart right now is to find what? What can that beginning part give me? Moles. That's not going to change when you dilute something. Now, you could do this in 2 ways. Honestly, I will show it to you in another way, but this information will help us in the long run right off the bat. So, where's my calculator? I had a calculator. You see a graphing calculator? Underneath that. I saw Tyler looking at it. He wants it for his tests. So what you can do, simply put, is that. Oops. Okay?
It's weird.
Yes.
0.025.
What did I do?
Oh, it's 0.025.
Thank you.
My goodness. Who said that? You're gonna math bad. Your next test is gonna be half.
Mine or his?
His.
Because he's right.
No, Edgar, remember that one time? What?
All right. Yeah, that one time. That time.
Yeah.
Now, you can do this 2 ways. You could simply, this is how I would do it, is just take this now, and now put it over my total. So this is how I would show it. Now I have a new molarity. Does anybody have another way they could have done this? A little short, like, it's not much more work. Or maybe it's the same amount of work. Instead of just doing it like that, I'm diluting it. Ashley? Yeah, okay, so Ashley's saying, what if I would do it right here? Oh, I can't reach that high. Yeah, I got you. Thanks, Edgar. Right there, but the problem is that would tell me I have a different amount of moles. I still have the same amount of stuff floating around in that solution. There's a dilution that you could do this. Okay? I just want to show it to you because some of you, this is easier for you. You get it. So what I could have done is this. Please kind of pay attention and hopefully this will register. And check out what I'm doing. I'm keeping it in milliliters. So now I don't know my new concentration, but my new volume would be 65 mils. And because of that, I should get the same answer. And you can check it if you like. Why do I get the same answer? Check out the left side. What is that basically doing? That is finding, in essence, moles. Now, I know you're like, wait, that's by milliliters. We're going to learn something called millimoles soon. I know, it will be a mind blow for you. It's a time saver.
I learned it for that.
M-M-O-L. No, 2 M's. 2 lowercase m's. All right. So, either way, you get the same answer. That's just the first one. They get more complicated. Okay? So, let's talk about the next one. B, a sample of 70 mils of HBr is added. So I have 70 mils okay, so basically what that is, and hopefully you're recording this correctly, so you're putting them both together. Okay? Keep your eye on the prize. It's moles over volume, right? It's moles over liters, and that's it. Is that a strong acid?
Yeah.
It is. And for some of you, like, hey, you just tell me, I don't know. There are 7, HCl and HBr, both strong. Okay, so what do I need to do with that one? Find the moles. Find the moles of that. So if I just quickly do that, I'm gonna show it slightly in a different way. Okay. So I guess I'm going to tell you a little secret. You guys, if you would multiply, let me show you something. If you would take this is totally on the side. This is for next chapter, but if you've ever wondered this. If you took that and then you divided it over milliliters again, it gets rid of the milliliters. It gets rid of the millis. So if you're multiplying by because that's what this is right here. So if you would take that and get it by milliliters and then divide it over an overall volume of milliliters, it still comes out. So if you're ever wondering how that would work, that's how we would get a millimole, because you're multiplying moles times milliliters. But to be safe for now, so we have, what's the point of that? This is the point. You put the total moles over the total liters. Okay? So what do I have? I have 0.003 plus 0.0035 over, what is the original 25? Edgar, you're taking up your entire free space.
Yeah.
And one problem.
I told you. I can't.
He's trying to do this on a sheet.
I tried.
It crinkled it.
I tried. It didn't work.
Oh, Edgar.
Where'd you get the point 0.003?
So this was the original amount. This is HBr, or HCl. And this is from the HBr. Isn't that 0.003 in the beginning? Yes. So we're going to use this a lot, because that's what's lying initially in my solution. Okay? Hannah.
So after you have the concentration of H+, do you have to take the negative log of that to find the pH?
You would, but I don't think that's the question. I thought it was just the... I was looking at B. Thank you. I kept looking at B, concentration of H plus only. Thank you. So let's quick go. Sorry, I was looking at the wrong problem. So after you're done with this has to go into pH equals negative log of whatever you found. Thank you, Anna. Same thing here. So I'm going to do one. Let's do one of these to make sure that we're on the same page. It helps when I'm looking at the right problem. So guys, each time I'm hearing murmuring, this is how much H plus you have in the beginning. So if I'm adding the HBr to it. And then with the HBr, I'm adding volume as well. So I have more H plus in there, but I also have more volume. So that's where all that's coming from. So what I got was this. Careful on rounding. So now I just need to take pH equals negative log of that. Suggestion, you get that answer, don't get rid of it. Leave it in your calculator and then just hit negative log second answer. You'll get a better result. And if I'm not getting the same number, let me know, because I'm going backwards and trying to type this really fast. Is anybody else getting that? And maybe I didn't get that right. Is it something else? I'm not acting like I'm positive.
We got,
Let me add it up again. Gosh dang it, 0.068?
yeah.
Oh my goodness.
If you're just writing and not calculating with me, that's not cool. No, well, you're the teacher. I am aware.
You're supposed to be teaching us how to.
I'm going to teach you how to throw a calculator really accurately and fast, okay?
Please.
So I get
Skills.
1.16. By the way, I took a left today at the dreaded intersection, and 35 seconds later, I see the white car coming and approaching the stop sign. I'm like, I missed it, thank gosh. So yesterday, I have to share this with you. It's on footage. I have to quickly do this because we don't have a lot of time. Here is the library, okay? This is the street, okay? This is the teacher's parking lot where Evelyn parks where she shouldn't be, in the middle, and many others of you, which is starting to frustrate me. So I'm right here, okay? There's two lanes. Okay, this is the library. The stop sign over here, Mason, that means you stop. There's a bus. Okay? I am not kidding. I'm here, okay? The bus, I can start hearing it. Okay? And I'm like, oh, it's gonna slow down. There's nobody else. There's nothing else. And I hear it actually, not because it's getting closer, because it's speeding up. I hear it getting louder. And it's right here, and I kid you not, I had to do this, boom, boom, and it just went by my foot. And we watched it on the security cameras yesterday. And Ms. Junkins was like, oh! No brake lights at all. I would have been run over. And I'm not exaggerating, because I'm like, did I see this right? Like, I don't know. Did I see this right? And we watched it, like, oh my gosh. Like, I didn't do it. If it was slippery and I would have pushed and slipped, that was it. That'd be it. Neubauer's teaching AV Chem.
Can you share that? Can you get the footage?
I want to get it. I do. I'm going to ask her later if I can actually get the footage. It was awesome. I mean, not awesome, but awesome.
It was great.
Because I'm so athletic and agile, I'm alive.
Tennis saves how hard was your blood pumping out?
I was confused. I'm like, whoa. I'm in a bright red jacket. I'm like 6'2". I'm not like, like hiding, Okay, let's go. We got to finish these. This all helps.
What if the bus driver is just like a student?
Mason, did you pay her?
Wait, it was a her?
Yeah.
Oh boy. Do you know what bus it was? Like,
Is it a relative? Is it a relative?
do you know what bus it was?
I don't. Okay, guys, let's go. What does that give me?
7.
I wish I were exaggerating. I'm really not. My wife doesn't believe me though. She's like, well, okay. You're fine.
I don't think she wants to believe it.
What does this give me? And we don't have a lot of time. We got to get to one more thing yet. Not number-wise, just in general.
Wait, how do you not get the dollar to start?
I don't know. That's what I'm asking.
It makes more water.
What?
Does it make more water?
No, it does not make more water. Water makes water.
It makes it
It gives me OH. Guys, it's a strong base. It's a strong base. So, whatever OH concentration of that compound, of KOH, that's the concentration of OH minus. So technically I have 0.1 molar of OH. The problem is, I'm adding it to something else. So whenever you add, we learned this in the beginning in chapter 4, when you add new compounds, it's moles over volume. So this doesn't go away right here. This is, I keep using the same color. It's that. That's already in solution. So let's talk about what I get. This is an important one because every year whenever I do this problem, students really get confused, and after you see, they're like, oh, okay, these are like 4 different, completely different situations that all help apply this. So I have that much. Let's think about what I have. I add that, right, to what? To again, if I'm ever making a mistake, please let me know. I had a near-death experience, okay? It's going to take a while. I might make some mistakes. I tried to use that just last night. I was like, oh, hey, can you put the dishes away? I'm like, what? I almost got killed. Sorry, Nate, what?
They have security cameras in the whole parking lot.
Oh, it's everywhere.
Yeah, you're doing
No, I'm not exaggerating. I watched it from 4 different angles. Let's just say that.
Did you have slow-mo? Like, could you write on it like ESPN? Like,
I don't know.
analyze it?
Boom! And then he went here. And he's going here while the bus is going there. And bam! Guys, what does this do? Talk to me. H plus OH minus always makes water, right? I have equal amounts. So I can't even put this in a calculation. What pH is this?
7.
It is exactly 7 because they are neutralized. So pH, there's no calculation to show. I will repeat that. There is no calculation to show because I have the exact same amounts of both, so you have 0. And you're like, well, wait, but then how does that work for pH? It's different because I'm adding it together. I mean, if you had 1 times 10 to the negative 7th H plus, you could plug that into a pH equation. But when they're exactly neutral, or when they consume each other, then it's done. Last one. I want you to see the 4 different examples, because this, I believe, is a really good model. So now I have 100 mils. Okay, let's talk about this one. What does that do? Well, let's get to the math first. It's the same concepts for each of these. Now, before I move on, I could have written it like this and take care of it later, or I can take care of it beforehand. I'm going to leave it like this for right now, and I'll show you what I mean. What is wrong with what I've done? So either you take care of it right here, and you make that a 4, or you take care of it afterwards. But either way, that's how it's done. So now, what do? I add it. And what do I have in excess? So can someone tell me in a very short explanation what I now do? There's a couple things I can do. Yeah, no? Yeah, question.
Subtracting or adding?
Subtracting or adding, great question. It's all point of view. I add them because what's happening is as you add them, the H plus and the OH minus become water. So in essence, you are subtracting. But in chemistry, a lot of times, it's not about subtracting. It's about creating and then whatever's left. So if it works in your head, like, yeah, you subtract those. Great, go with it. Okay. But I view it as I'm adding because they're opposites. Okay? That's a valid question. What can anybody explain to me what I do with this? I need pH. So I need OH or H plus concentration. So I need moles over liters. That's how many moles I have now. So what do I need? I need molarity. So I need to put this over, is it that? Is that the total? Right? Because it's 100 mils plus 25 mils, right?
Can't you just subtract that from?
You don't need to subtract your molarity.
But don't you have to put it in terms of?
Yep. So guys, this is POH now. Remember, if it's OH, I use POH. If it's H, I use pH. So now I just take negative log of 0.008, which I don't love having just that number, but that's all I got on that. So POH, again, as I've said many times already, that base problems are always more work than acid problems. Why? I'm not done yet. What do I need to do with that? 14 minus that, okay? And then I'm home, okay? Then I'm home. It should make sense that my pH, oh jeez, my pH is basic, above 7, because I have OH. We still got like 7 or 8, or 6. All right. I want to quickly show you one last quick thing. It's a little demo.
You're just gonna dump it.
I don't get why you're not like I was supposed to. No, I get why you're not I don't get hung up.
Because they neutralize each other. OH and H plus, they eliminate each other. So I have 0.001 more of OH than H plus. It's not going to be due today. I haven't even taught the whole backside yet. Let's make that. To be determined until I teach it. When I tell you I will tell you 2 days before it's due. How about that? I haven't taught the last 2 problems in the back yet. Actually, I haven't taught you the last 4. You should have the first 4 done if you haven't already. All right, so quickly here. Let's just talk about this. You might want to put this in your notes. Give me a sec. Get this down. Stay with me. We go over a minute. This is what I want you to think. This is going to get you started. So when you run into these, some of you are going to be able to easily self-teach yourself. If not, it's okay. But I want to get you started on this. This is what's hard. When we start dropping salts into water, you will have to be able to talk about how it behaves. Well, what do you mean? Because salts make different solutions, acidic and basic. Okay? So this is what I want you to think about. What happens if it gloms on to H plus or OH minus? So let me show you what I mean. Each one of these, I'm going to split this. I'm going to do an H plus or an OH minus. An H plus, this is just what you think about. So this would be HCl, this would be NaOH. This would be HCl, this would be FeOH3. Okay? What am I doing? I'm putting the H plus onto the anion, I'm putting the OH minus on the cation, right? The positive and the negative, the positive and the negative. This is just what you need to think about. For those of you that decided to pack up 6 minutes early and not writing this down, that is such a horrible decision. This is going to be the hardest part of your test. And for you to think that I would spend time not doing something important. Poor decision with a 4-day weekend coming up. So, how do I know what is what? I know there's 7 strong acids, and then first group or 2A CBS are strong bases. So I don't recognize that. So this is a weak acid. This is a strong base. Why? First group OH, right? HCl, strong acid or weak? Strong. NaOH, strong or weak? Strong. HCl, we just said it. FeOH3, weak because it's not first group or second. So what's the whole point? This is, and by the way, this is not how any book teaches it. The books are extremely confusing. I came up with this on my own. Or at least I think I did. I'm sure someone on YouTube's now going to comment like, no, you did not. This is what I'm looking at. Let's get rid of that color. Oh, jeez. That's strong. This is strong. And both these are strong. So what I do is I think about how it's going to behave. Okay? What I have here, this first one is Na2CO3. This is universal indicator. You need to know this. Universal indicator, it's neutral when it's green. Okay? When it becomes acidic, what color is it? You guys know? Just based on some things you've seen? Red. The closer to red, the more acidic. So what would be basic? Blue or purple. So it's the rainbow. So purple or blue is base, red is acidic, green is neutral. So what is this first one going to act like? So you pick the one that's going to win, quote unquote. So it's going to act like a base. It should be basic. Let's find out. Purple. Basic. Huh? The what? Oh, no. Oh, I got to get that done. This next one. Check this out. NaCl. It's a strong acid and a strong base. So what do you think that's going to be? It's going to be neutral. Let's find out. Please be neutral. Sometimes neutral's finicky. Hey, we'll take that. That's green. So this last one, unfortunately, it's already yellow, so that messes things up a little bit with our colors. But it acts more like an acid than a base. So this should be red, but with the yellow, it's going to be a little messed up. But we'll take it. So it goes to a reddish area. So we're going to see how that applies. But all you need to do is you look at your salt, all right? And then you think, okay, if I add an H plus and an OH minus on each of the ions, is there a heavy tendency of being acidic or basic? We can figure that out by which one creates a strong. There will always be a strong. So the question is, well, what happens when there's 2 weaks? There's no such thing. There will always be a strong. Okay? So we're going to use that information. I will probably make a video to show you how to do one of these with a salt equation. Please try to do it. I will not do it in any accent. Okay? Or maybe you want me to. I don't know. Maybe I'll send 2 of them. One with